Hi, welcome back to Coding for Beginners. In this video we're going to write something a little bit more interesting than last time, and that's a number guessing game. So I'm going to start off not actually by writing any code, but by doing something a bit different. I'm going to write a hash and then just a load of gibberish and click run, and we can see that we don't get any errors. If I deleted that hash, you would see that I got this nasty error, undefined local variable or method, or however you want to pronounce that. And this thing that I'm doing is called a comment. Any line that begins with a hash is completely ignored by Ruby, and that turns out to actually be really useful. It means we can leave notes to ourselves or to any other programmers who might be reading our code. And one of the things I like to use that for is to plan out how my program's going to work. So when you're writing anything of any real complexity, be it a report or an essay, it's kind of unusual to just start writing the introduction and plow through until you hit the conclusion and then stop. Much more common approach is to put out some headings, maybe go back and point some bullet points under each heading, go back and then flesh those out a little bit, maybe rearrange things a little along the way. And writing code, it really can be quite similar to that. So I'm going to start off by just giving this a title, which is number guessing game. And then I'm going to think through the steps that I need to perform in order to make a number guessing game. So pretty much the first thing is always going to be print some instructions so we can tell the user what to do. Next we need to think of a number. Then we need to get a guess from the user. And then we need to check if it's right or not. Fairly simple. So I haven't written any code, but I've already figured out, I guess you could call it the algorithm or the approach that I'm going to use to solving this problem. And that can really lower the cognitive overhead when writing code, which, let's face it, is already pretty complex sometimes. So first thing is to print some instructions. That's pretty easy. We used the puts function in the last program to output text, or output a string, should I say, and we're going to do the same thing here. So I'm going to say puts, guess the number between, let's say 1 and 10, which I think is a fairly common range to use for a number guessing game. Then I'm going to think of a number. So I'm going to make a variable called number. I'm going to set it to be equal to 7, which seems random enough, doesn't it? Next we need to get a guess from the user, and this is not unlike when we got the user's age in the last video. So we know we're going to get a number, so I'm going to have a guess variable, and it's going to be equal to get, that is to get a string of input or a piece of text from the user. I'm going to use .strip to take all the invisible characters off the end, just like in the last program, and because this is a number I'm going to use .to_i to turn this into an integer type variable. The last thing we need to do is to check if it's right or not. And we can do that using a conditional, just like we used in the last program, but there'll be one slight new thing. So I'm going to say if the guess is equal to the number, and put the word end in now so I don't forget, I'll come back and say puts you win. Something fairly simple. So I'll run this and check that it works. Guess the number between 1 and 10, I'm going to guess 7, and it says you win. So it works. Now this is a pretty simple program, and it just about fulfills the criteria of being a number guessing game, but what I really was shooting for was what I would call the minimum viable product. Something that only just fulfills the criteria that I've set out. And this is a great way to approach writing programs because you can focus on solving your core problems without worrying about ancillary details. So we can add to this now that we've got something working. And the first thing I want to add is an extra bit of feedback to say you got it wrong, because at the moment if we're guessing correctly there is no output. You'd be forgiven for thinking that this program just crashed. But first I want to draw attention to this double equals here. This is how we ask if two things are equal, and it's not to be confused with the single equals, which means take the thing on the right and put it into the variable on the left. One of the most common programming errors is actually to forget the second equals and to go for a single equals. So let's see what happens when we do that. If we guess 7, it says we win. But if we guess 5, it still says we win. Or 4. Or indeed, if we just type out the word 4, it still says we win, which is obviously not correct. So what's happening here is computers are really bad at figuring things out based on context, unlike humans. And what we're really asking here is, can I take the contents of the number variable and put it into the guess variable, which we always can. So the result will always be true, and we will always say you win. So because computers are bad at figuring things out based on context, we use 2 equal signs to differentiate the 2 things. And in this case, everything works fine. So let's get to providing some feedback for people who weren't so lucky and guessed it incorrectly. Just like in the last program, we can use the else statement to write some code which will run in every other situation. So here I'm going to say puts too bad. We'll run the program again. When we guess correctly, it still says you win. And when you guess incorrectly, it now says too bad. So this program's it's a little better, but I think we can improve things further. I think a game where you only get a 10% chance of winning is not very good. So to improve things, I could take this code and repeat it several times, but we can do something a little bit better. I'm going to highlight my conditional and where I get a guess from user and the comment too, and hit the tab key, and that will indent all of this code. And then before it, I'm going to write 5.times space do, and after it, I'm going to write the word end. So we'll run the program again and see what happens. Now I'm going to guess 5, and it says too bad, but then it waits for me to guess again. So I can guess 4, or 3, or 2, or 1, and too bad I didn't get it. But now I've got a 50% chance of winning instead of 10, which is an improvement from my perspective. So this thing that we added is a thing called a loop. And it's a slightly unusual kind of loop for some languages, but in Ruby it's perfectly normal. Numbers like 5 have a method called times, which is you can think of it as their argument is really a block of code, everything between the do and end here, that will be repeated that many times. And loops are really a foundational construct of programs, along with conditionals and so on. There are probably hundreds of loops running right now on your computer, including ones that are running around 60 times a second, updating everything that's on your screen, checking to see if there are viruses in your files, if you've got an antivirus scanner running. They are all over the place. And they allow us to do really useful things without having to duplicate code over and over and over again. So I haven't won this game yet, which is kind of annoying. Because I haven't guessed 7, but if I do guess a 7, we can see there's a slight problem. So it says I win, but it's still waiting for me to input another number, in which it will say too bad. Or I can just make it say you win over and over and over again. This is a little bit silly. What would be much better is if after you have guessed the number correctly, the program stops. So let's make it do that. After I say puts you win, I'm going to add the word break. I'm going to run the program again, guess a 6 and then a 7, and you can see where it says you win and then the program exits. And if I guess a 4, a 5, a 6 and then a 7, it exits then. So this word break, you might notice, has been coloured in a lightish blue, the same as if and else and do, and that's because it's a key word, a word that in this case controls the flow of the program. What it means is break out of this loop early without running the full 5 times. You can imagine it almost as if you're driving round and round a roundabout and you intend to do it 5 times, but then you take an exit early, which is maybe a bit of a silly way to drive, but hopefully it gets the idea across. So this program is improved a bit, but it's not really got any staying power. Once you've figured out that the answer is 7, there's no real reason to run the program again. So let's make it random instead. So up here where we set the number variable to 7, I'm going to delete the 7 and instead put rand space 10. So this random function should give us a random number up to 10. Let's try it out and see what happens. So I'm going to guess 5, 6, 7. You win. Great. Oh, it was 7. That was funny. Let's try again. 5, 6, 7. Too bad. You win. Don't win. 9. Too bad. Great. So now we've got a random number. I think this game still has a bit of a problem. And in fact, I would go so far as to say I don't think it really qualifies as a game anymore. Or a game, it never really qualified as a game in the first place. And that is because there isn't a strategy to this game. You have a 50-50 chance of winning every time, and I think that makes it more of a lottery than a game. So let's change things up a little bit to make it possible for this game to have some strategy. And I'm going to do that by, instead of saying too bad when the user guesses incorrectly, I'm going to give them a bit of a hint and tell them whether they should go higher or lower. So let's delete the puts too bad, and in its place, let's say if the guess is less than the number, and we'll put the word end in so we don't forget, we're going to say puts higher. And in other situations, using else, we'll say puts lower. Then we'll retry the game and see what happens. So I'm going to guess 5, and it tells me I should go lower, so I'll pick 3, lower, 2, 1, and I win. Brilliant. Let's try again. 5, it's lower, 3, lower, 2, 1, you win. That was 1 again. 5, higher this time. And 8, lower, 7, lower, 6, you win. Brilliant. So I think this qualifies as a game now because it has a strategy. I can pick a number that's halfway between the range, and I get told whether it's higher or lower. And that means I eliminate half the possibilities. I can then pick a number roughly halfway through the remaining range, and then I get a higher or lower. I eliminate half the remaining possibilities again, and then I can hopefully pick the correct number. Let's try it a few times to see. So 5, lower, 3, 2, I win. Now, I reckon with this strategy, I can win this game every time, and that puts it into a category called solved games. 3, you win. 3, 2, 1, you win. Yeah, I'm pretty good at this game. Other solved games include noughts and crosses, or maybe you call it tic-tac-toe. And if we're talking about computers, I believe checkers or drafts is also a solved game. So you should never play checkers against a well-written computer program, because you'll probably always lose. So I've played this game a few times now and everything seems fine, but I actually happen to know that there is a bug in this program. And one of the issues with randomness is it can take a few attempts to really prove that. So I'll play it one more time, and if it doesn't trigger the bug, we'll just talk about it. So the bug in this program is actually that the number we have is not between 1 and 10. It's actually between 0 and 9, and that's completely my fault. I was slightly misleading about what this rand function did. And what it actually does is give you a number between 0, inclusive, and the number that you give it as an argument, exclusive. So 1 less than the number. So what we really have is a number between 0 and 9, not between 1 and 10. Now, you could argue that you could just change the instructions to say between 0 and 9, and then that would fix the problem. But I think that's a little bit cheeky and not really within the spirit of fixing the bugs. So how else can we solve the problem? There is an alternate way that we can use the rand function to solve this problem, but I'm going to show you a different way, mostly to make a point. So if we have a number between 0 and 9, we could add 1 to it, and then it should become a number between 1 and 10. And it's tempting to write code that looks like this. So number equals rand 10 plus 1. And we know what we mean, but we've already said computers are not good at figuring things out based on context. they can only really follow a fairly simple set of rules. And how this line reads at the moment is actually 10 plus 1, which is 11, passed to the rand function. The arithmetic operators are performed first. You may have been taught at school an acronym such as BODMAS or BIDMAS. I think different schools use different acronyms, which is to say you do things that are in brackets first, and then multiplication and division, and then addition and subtraction. And it's exactly the same here, except the function application, if you like, is done last. But just like in algebra at school, we can use brackets to force a different order of operations. And this is actually something that we have been omitting all the way through so far. So this puts function up here could have had brackets on there and still work. In Ruby they are optional, but in this case we use them to disambiguate what we mean and force the order of operations. So what we get is the rand function with 10 passed to it, that is a random number between 0 and 9, and then we add 1 to the result. So that fixes things for us. So really there was two ways we could have spotted this problem. One of which is sometimes the answer was 0. So we would guess 1 and it would tell us it was lower. But the harder problem to spot is it was never 10. And I think you would have to be a pretty dedicated tester and record all of your results before you really noticed that that was an issue. So that's everything for this program. It's a little bit more complex than the last one, but really we only added 2 new things. We added this double equals for comparing if two things are the same to each other, and we added the concept of loops also. So I hope you learned something. In the next video we're going to look at writing a simple version of the classic hangman game. Thanks.